Okay, so we are in section 5.1 in transitional algebra, which is simplifying rational expressions first. Okay, number 1, you're going to have 6y to the 5th over 3y squared. So if you'll remember, this number part, this 6 over 3, you're just going to reduce that like you normally would any fraction. So 6 over 3 reduces to 2 over 1. Then you're going to use the rule, the exponent rule, that says when you are dividing y over y, if you have y over y, you're going to use the rule that you subtract those exponents. So when I do y to the 5th over y to the 2nd, that's going to leave me with y to the 3rd up top. So all you have left in the top is the 2 and the y to the 3rd, and all you have left in the bottom is this 1. And so since you just have 1 left in the bottom, you don't need to write it. So that's number 1. Number 2 is similar. You've got 54 s to the 9th over 60 s to the 10th. Now, if you'll remember, the rule that what we learned how to do in class is if we aren't comfortable with reducing our fractions, I know this is far away, but so that number part, I have 54 over 60. So remember what you can do with that. After you have the fraction that you're trying to reduce in the calculator, you can hit the math enter button. And once you hit math enter, it'll reduce your fraction. So that one will reduce to 9 over 10. So this 54 over 60 reduces to 9 over 10. Now, if you'll notice on this one, I have s to the 9th in the top and s to the 10th in the bottom. So when I subtract, technically, if I do 9 minus 10, I'm left with -1. So if you have a negative exponent left, that just means to put the s in the other side of the fraction bar. Or you can think of it as these 9 s's cancel out 9 from out of here, which means I have 1 left over, but it's in the bottom. So if you'll look at what you have left, up top you just have that 9. And in the denominator you have 10s. So 9 over 10s is what you're left with on number 2. That red doesn't erase very well. All right, so I'm not going to use the red anymore. It doesn't erase like I like it and need it to. Wasn't anticipating that. So now if you'll look at number 3 on your worksheet, this one's a little different. Trying to get it as clean as I can so it won't be on there the rest of the time. So on number 3, you have 2a minus 4 over 2. So starting with number 3, if you have any factoring that needs to occur in the numerator or the denominator, you have to take care of that before you can do the reducing. So if you'll look in the top, remember the greatest common factor that we learned from in chapter 4. Since 2 goes into both of these numbers, you've got to pull it out. Pull out the 2, which means you'll divide both of these by 2 and put in parentheses what is left, just like greatest common factor from last chapter. So if I divide this by 2, I'm just left with the a, minus, if I divide the 4 by 2, I'm left with 2. I still have a 2 in the denominator. So once I do that, the 2's will cancel each other. This 2 over this 2 will reduce to 1. So all you're left with is this a minus 2 as your final answer. Number 4, you've got 2x minus 12 over 2x plus 12. So once again, anywhere there is factoring in the top or the bottom, you've got to take care of that first. So if you'll notice in the numerator, since 2 goes into both of those, just like on number 3, you're going to have to pull that 2 out put in parentheses what is left. So if I divided this by 2, all I'm left with from the first term, or the first part, is the x minus, if I divide this by 2, I'm left with 6. Now do the same thing in the bottom. Again, 2 goes into both of those, so you'll pull out a 2. Divide them both by 2 to see what is left, which will be the x, this time plus, divide the 12 by 2 to get 6. So once again, your 2's cancel each other. You've got a 2 in the top and the bottom, so they actually turn into a 1. So all that you're left with in the top is x minus 6, and in the bottom you are left with x plus 6. So x minus 6 over x plus 6. Okay? All right, moving on to number 5. All right, number 5. You've got r squared minus 1 over r squared minus 2r plus 1. R squared minus 2r plus 1. So again, factor first. So on the numerator, if you'll notice, I'm looking for factoring. There's nothing in common like in the last problem, but I do notice that those are both perfect squares. 1 is a perfect square. So remember that factoring that we did called the difference of perfect squares. So it's going to have 2 factors. How do you get the r squared? Well, how do you get r squared? There's only one way to do that, r times r. What's the same number when you multiply it together that gives you 1? Well, that's going to be 1 times 1. Now remember, your signs when you're doing difference of squares are always different, 1 plus, 1 minus. So there's the factoring in the numerator. Now, again, in the denominator, you're going to notice there's 3 terms. So remember, when we had the factoring the trinomials, we had the good kind and we had the bad kind. Remember, the good kind is when it was just r squared up front. That's the kind that we like the most because, again, there's only one way to get r squared. R and r. Now, here's where we had to find the numbers that multiply to equal 1 and add to equal -2. Now, this one has a higher chance for a sign mistake. So remember, if you want, you can go to your y equals and clear it out. Put this number, the last number, the positive 1, in your y equals. So you'll do in your y1, put 1 divided by x. So 1 divided by x. Then go down to your second y equals and type in the same thing, 1 divided by x, but then put in plus x. Then hit second table. So remember, what you're looking for is this middle number. It's sign and everything. So I'm looking in this y2 column for -2. So once I find that -2, where I have it highlighted right now, the other columns right here, so see, I found the -2. The other 2 columns are the numbers that you're going to use. So you'll notice that you're going to use -1, -1. So again, now, once everything is factored, you're looking for common factors that can be canceled or turned into 1, because anything over itself is 1. So now all I'm left with in the top is r plus 1, and in the bottom, r minus 1. All right, number 6. Y squared minus 5y plus 4. Sorry, I'm going to have to. All right, number 6, y squared minus 5y plus 4. Over y squared plus 2y minus 24. So again, factor first. We're going to factor and then cancel. So in the top, again, it's a trinomial, but it's a good trinomial since it's just y squared. Since it's just y squared, I'll use y and y. Now, after I do the y and y, again, if you need to, go put that plus 4 in your y equals. So you do 4 divided by x, and then 4 divided by x plus x, and then look for your negative 5. So when I find that, I'll see that my numbers are negative 4 and negative 1. So there's the top factor. Then the bottom, same thing, y and y. Put negative 24 in your y equals. So you'll have negative 24 divided by x, and then negative 24 divided by x plus x. And you're looking for positive 2 in your y2 column. And once you find that, you'll see that you're going to use a positive 6 and a negative 4 are going to be the numbers that multiply to negative 24 and add to 2. So once you've gotten the factoring done, you're looking for common factors in the top and the bottom. So that y minus 4 cancels that one. So your answer that you are left with is, in the top, you've got y minus 1, and in the bottom, y plus 6. All right, number 7. All right, when we get into number 7, this is where we start doing multiplying rational expressions. So let me get this cleared. Now, multiplying rational expressions is actually very similar to just simplifying them. Well, the first thing you're going to do is go through and factor every single spot that you can. So on number 7, where you've got y to the third over 4y plus 32, times 4y plus 32 over 4y to the 8th, okay? So again, you're going to go through and factor everywhere that you can. I can't do anything with the y to the third, so I'll just leave that like it is. So what I'm doing right now is just rewriting the problem in its factored form. So I'm just bringing down the y to the third. Now, when I look at this denominator, I notice that they have a greatest common factor. That 4 will go into both of those. So I'm going to pull out the 4 from here, put in parentheses what is left, which means I need to divide these. So I'm going to have y plus 8. Now, just bring down the times. Again, there's a 4 in common here, so pull out the 4. When you divide, again, you'll have y plus 8. Now, in the denominator, I can't do anything with this factoring y, so I'm just going to bring down that 4y to the 8th. Now, once you've done all the factoring, the way I like to do it is look for any parentheses, any factors that are in parentheses that are the same in the top and the bottom, and then cancel them. So I'm going to cancel that y plus 8 with that one. Now, once you have done that and gotten rid of any parentheses that are the same, just multiply what's left straight across the top and then straight across the bottom. So in the top, I've got y to the third times 4, which just leaves me with 4 y to the third. In the bottom, I have 4 times 4 y to the 8th. So that 4 times 4 gives me 16 y to the 8th. Now, just like we did on problems number 1 and 2, that's what we're left with. We are just now left with one simple fraction that we need to reduce. So again, the 4 over 16 reduces to 1/4. And again, if you wanted to math enter that, that's fine. Now, again, I have y to the third over y to the 8th. So when I subtract, I'm going to have 5 y to the 5th left. But I need to make sure I put it in the right spot. If you have y to the third in the top and y to the 8th in the bottom, your leftovers are going to be where you had the 8, not where you had 3, right? You're going to have your leftovers where you had the most. So I'm going to have my y to the 5th left in the bottom. So up top, all I'm left with is that 1. And if your 1 is the only thing that's left in your numerator, you do have to write it. You just don't have to write 1 if that's your only thing left in your denominator. But if it's left in your numerator, you have to have it. So I have 1 left in the top and over 4y to the 5th left in the bottom. So 1 over 4y to the 5th. All right, number 8, y squared minus 9 over y squared times y squared minus 3y over y squared plus 6y minus 27. So lots of factoring and lots of different kinds of factoring to be done on this one problem. So over here, this y squared minus 9, because remember, I'm going in to factor everywhere that I can before I can do any canceling, okay? So this y squared minus 9, those are 2 terms, so it's either greatest common factor or difference of squares. I look for something in common first, but there's not anything. But I do notice that they are both perfect squares, so that's a difference of perfect squares that I'm going to write in factored form. So to get y squared, I'll need the y and y. To get 9, since 9 is a perfect square, the number that you multiply together that's the same to get 9 is 3 and 3. And then your signs are 1 plus and 1 minus. So y plus 3, y minus 3. Over, can't do anything with y squared, so I'll just bring it down. Up here, I have y squared minus 3y. So again, 2 terms. But when I look for something in common with this one, I do see something in common. They actually both have that y. So I'm pulling out the y that they have in common, putting in parentheses what is left. Well, if I pull out a y, what's going to be left is these same exact things. They're just both going to lose that y that I pulled out. So if I had y squared, now it'll just be y. Minus, if I pulled the y out of here, I just have the 3. So there's that one in its factored form. Now, the last spot I have to factor is this denominator. It's a trinomial. It's 3 terms. And again, it's a good one since it's just y squared. So since it's just y squared, I'll use y and y. This is the number that you'll put in your y equals. So you have negative 27 divided by x, and then negative 27 divided by x plus x. And what are you looking for? You're looking for that positive 6 in your y2 column. So if once I find that positive 6, I see that I can do a positive 9 and a negative 3. So again, just like the last problem, once I have everything in its factored form, I'm looking for binomials that are the same. So there's a y minus 3 in top and bottom. Now, also, look what you have here. Actually, let's go ahead and write out what we have left after we canceled what was in common. So up top, I've got y plus 3, y minus 3, and that y. In the bottom, I've got y squared and, whoops, y squared and y plus 9. So now I do notice there's one more thing I can do to simplify that. You notice I've got this y and that y squared. So if I use the exponent rule and subtract my exponent, this y here cancels out one of the y's there. So since I have y squared and I canceled one of them out with that one, I still have y left. So here's what your answer should look like. You should have y plus 3, y minus 3 up top, over, I still have that y, and the y plus 9 in the denominator. All right, number 9, the last multiply. So up top, I've got x squared minus 25 over 6x plus 24 times x plus 4 over x minus 5. So again, I'm looking everywhere I can to do any factoring. Up here, 2 terms, both perfect squares. So there's another difference of perfect squares. So to get x squared, I'll have x and x. And the number that's the same that you multiply to get 25 would be 5 and 5. 1 plus and 1 minus. In the denominator, again, 2 terms, but there's not, this time they're not perfect squares, but I do notice that they do have something in common, right? They both have the highest thing that they have in common is that 6 goes into both of these. So here, I pull out a 6 and put in parentheses what is left. So if I divide these both by 6, here I'll be left with an x. Plus, if I divide that 24 by 6, I'm left with 4 times. Now, look at this fraction. The good thing about this fraction is there's no factoring that needs to be done, right? X plus 4, there's nothing in common. There's nothing I can pull out. It's not a trinomial. Same with the x minus 5. So I'm just bringing that fraction down. Now I'll do my canceling. Well, let's see. That x plus 4 will cancel that one. And that x minus 5 will cancel that one. So all I'm left with up top is the x plus 5. And in the bottom, I'm left with 6. Now, when we get into number 10, 11, and 12, these are the last 3 problems of the section, and they are all division problems. Now, division is very similar to multiplication because the actual definition of division is to multiply by the reciprocal. So all we're going to do is flip that second fraction and then just work it exactly the same as we've been working these multiplication problems. All right, number 10, you've got 50x to the 7th over 2y to the 7th. This time it's divided by 625x to the 3rd over 10y to the 4th. So again, divide actually means to multiply by the reciprocal. So I'm going to keep my first fraction exactly as it is. So 50x to the 7th over 2y to the 7th. Now I'm going to turn that division into a multiplication symbol and then flip the second fraction. So that's going to turn this division into multiply by the reciprocal. So up top, I'm going to have 10y to the 4th. And in bottom, I've got 625x to the 3rd. Now, I'm looking for something in here to factor. Since I don't see any general factoring and no trinomials, no difference of squares, no greatest common factors, I'm just going to go ahead and straight multiply across on top and bottom to get one fraction that I can then reduce. So when I multiply up top, I've got 50x to the 7th times 10y to the 4th. So 50 times 10 gives me, what is that, 500? X to the 7th, y to the 4th. So that's just exactly what it says, x to the 7th, y to the 4th. Now, in the denominator, so I don't make a mistake, I'm going to put that in my calculator. I've got 2y to the 7th times 625, x to the 3rd. So that 2 times 625 gives me 1,250. Y to the 7th, x to the 3rd. Okay, and I'm going to write these in alphabetical order so it'll look like my top one. So I'm going to have x to the 3rd, y to the 7th. Now, just like we did at the very beginning of this section, I've got a fraction that just needs to be reduced. Now, I would probably put this number part in your calculator and then math enter it. So I have 500 divided by 1250. Hit enter, which gives you a decimal, which we knew it would. So math, enter that decimal to see what this fraction reduces to, which is 2/5. Now, look at your x's. If I subtract my exponents, I have x to the 7th in the top and x to the 3rd in the bottom. So I'll have 4 left over. And your leftovers are always going to be wherever you had the most to start out with. So if I have x to the 7th in the top and x to the 3rd in the bottom, that'll leave me with x to the 4th in the top. And then do the same thing with your y's, but this time you have y to the 4th in the top and y to the 7th in the bottom. So I'm going to have y to the 3rd left. And again, put your leftovers wherever you had the most to begin with. And since I had the most in the bottom this time, my y to the 3rd will be left in the bottom. So let's look and see what we have left. Up top, you've got a 2 and an x to the 4th. And in bottom, after you reduce this fraction, you had that 5 and y to the 3rd. All right, 2 more. Okay, so just remember, these last 2 are going to be division again. So what I'm going to do first, after I write the problem out, is I'm actually going to rewrite it again, but as a multiplication problem, right? Because you want to rewrite it as multiply by the reciprocal. So on number 11, I've got 8y plus 72 over y divided by y plus 9 over y. So the first things first, I'm going to rewrite the problem. While I'm rewriting it, anywhere I'm going to factor, I'm going to go ahead and factor. Actually, I'll rewrite the whole thing first. So 8y plus 72 over y. Change this to times. Flip your other fraction. So y over y plus 9. Now I'm looking to see if I can factor anywhere. Look at this first numerator. You'll notice that they have numbers in common, right? So I need to find the biggest number that they have in common. So I'm going to try the 8 and see if it, because I know it goes into itself, right? 8 goes into 8. So does 8 always also go into 72, which it does, which means they have an 8 in common. So you got to pull out the 8. Put in parentheses what's left. If I took the 8 out of here, all that's left is that y. Plus, if I divided this by 8, I'm left with 9, because 72 divided by 8 gives me 9 left. All that I have in the denominator is a y, so I'll just bring it down. Over here, all I have up top is the y. Now, look at the bottom. It's just y plus 9. There's nothing in common. It's not a difference of squares, because it's not subtraction, and that's not squared. So that you're just bringing that down. Now you're looking for factors to cancel. Well, let's see. That y plus 9 will cancel that one. And what about this y? That y will also cancel that one. So look, all that you're left with is 8. So after you do all that work, all you're left with is 8. All right, last one, number 12. All right, y squared minus 36. Hang on. Over y squared minus 18y plus 81. Divided by 9y minus 54. Over y squared minus 8y minus 9. Okay, so once again, since it's division, before I do anything else, I'm going to rewrite this problem with a multiply and a flip the second fraction. So let's do that first. So everything is the same up front. So y squared minus 36 over y squared minus 18y plus 81 times, flip the second one, so y squared minus 8y minus 9 over 9y minus 54. So again, all I have done from the original problem is flip that second fraction upside down and change the division to a multiply. Now I'm looking at this and I see factoring all over the place. There's difference of squares, there's trinomials, there's greatest common factors. So I've got a lot of factoring work to do on this one. This first one, two terms, both perfect squares with a minus, which means that's a difference of squares. So how do we get y squared always with just a y and a y? The same number that you multiply together to get 36 would be 6 and 6. 1 plus and 1 minus. Now this denominator down here, it's a trinomial, but once again, it's the good kind since it's just y squared, which means I'll use y and y. Now, this might be one that you might want to consider putting in your y equals so you don't make a sign mistake. So this, I'm putting 81 in my y equals. So clear it out. 81 divided by x, and then go down to your second y equals 81 divided by x plus x. So your y equals should look like that. And then you're doing second table. What number are you looking for? You're looking for negative 18 in your y2 column. So once I get that negative 18 is highlighted, you'll see the numbers that make that happen are negative 9, negative 9. So that's what I'm using is minus 9 and minus 9. Times another trinomial. So again, y and y. So if you wanted to, again, it might be beneficial to go to your y equals and put negative 9 in there. So I've got negative 9. Whoops. Negative 9 divided by x, and then negative 9 divided by x plus x. So again, your y equals should look like that. Second table, what number am I looking for? I'm looking for negative 8. So once you get the negative 8 in your second y column, the other numbers are the numbers that you're going to use. So what you're using is a negative 9 and a positive 1. Now, in the denominator here, all I can do is they have a greatest common factor of 9. So I'm pulling the 9 out. Once I pull the 9 out and divide see what's left, I'll have y minus, when I divide this by 9, I'm left with 6. So there's what you're left with after you have factored everything. So now you're going through and hopefully going to be able to cancel some stuff to clean this up. So let's see, this y minus 6 will cancel that one. That y minus 9 will cancel one of these, just not both of them. You can only cancel one of them. It doesn't matter which one. So this, again, this y minus 9 canceled that one. That looks like all the canceling I can do. So what you're left with up top, you'll notice what you're left with is the y plus 6 and this y plus 1. And in the denominator, you're left with y minus 9 here. And what else? This 9 that you pulled out earlier is still there. So you can either put it behind the y minus 9 or in front of it, either way. So that is what you're left with, and that is your answer.